I know.
The tone sensitive.
That's what Miss Stone is checking off. So make sure you have that. Oh, of course, I don't have that up and going, do I?
Which is going to be what? What was homework last night as what you needed to get done, not the try?
3 and 4, 3 and 4.
Biscuits.
On what page?
84.
84. So, you guys should turn to page 84. Okay? Again, I'm practicing being direct. Please turn to page 84.
Okie dokie.
Okay?
You meant automated robot.
No, that was another thing, sir, that I need to be direct.
Look at. Did like at. All right. Connect. All right, so Stone's checking off as soon as it shows up eventually. Cool? All right, so let's talk about, I'm not going to go over 3 and 4. I just want to make sure that we're checking that you tried it, okay? But I'm going to be on page 87, and I'm going to kind of go through these kind of quickly, but I want you to stop me as soon as you're like, hey, wait. Now, I'm going to do the best I can to try and mimic the picture, okay? Forgive me if it doesn't look perfect. This is like -2, -5. Agree? Now, here's the hard thing here. This is like about 0.2, 0. And I won't do this to you on a test, and I apologize. And I know my picture isn't perfect. And this is like -4.2, 0. Okay, those would obviously be ones that we can't find the roots, but I'm just putting those in place so we can start doing this. So the domain, this is problem number 1 on page 87, okay? Negative what? You nailed it, my friend. Negative to positive infinity. All those domains of all of our parabolas will always be this. My range, though, I'm going to look at my y value. And the range goes from bottom to top. So it starts at -5 and it goes to infinity. Now, it's technically a hard bracket to a soft bracket. I'm not real worried about the brackets. Okay? Deal? Okay. Then it says, do we have a max or a min? Well, we have a min on this, and our min is -5. Our vertex, the max min is referring to where the vertex is. Is the vertex at the high point or the low point? It's at the low point, so it's the minimum. You look at the y value, and that's all you deal with on that. And then in this one, it asks for the roots. Now, friends, I know I made up these values, okay? If I ever give you one that your pattern graphing did not show, or you didn't see exactly where across the x-axis, just give me the question marks. I don't know exactly. I just had a list, 0.2 and -4.2, but I don't know it for sure. Okay? And then the vertex. The vertex we have labeled. That was just look at it and count where the point is. And then we go to the axis of symmetry, the AOS. The axis of symmetry is always x equals the x part of the vertex. That's always the case, not just today, okay? And I don't know how I can make you remember that. You know, it always drove me nuts when the teacher's like, you got to memorize that, and you're like, guy, okay. And then it says interval where it's increasing. Now, this is where I want you to kind of put your pencils down for a minute and just watch what I'm going to draw. Okay? It's increasing. I'm going to give you the terminology. As I go to the right on my graph, where is it going up? So it always starts from the vertex and it goes here. That's where it's increasing. So I use the x part of the vertex. So it's going from -2 And as I go to the right, it's going to continue to go up. Oh, yeah.
It's fine, but you attempted it. That's what I'm asking. You attempted it.
And you're going to see why I didn't go over 3 and 4 later today. And then you're going to actually be a little disappointed in me that I didn't show you the first way first. In fact, you all might dogpile me in the classroom going, you shut up, showing us. I'm like, I'm sorry. I'm wrong. I'm always wrong. All right. And then where is this interval positive? Positive. Yeah. So let me highlight where it's positive. This region is where it's positive. Okay? It means where it's above the x-axis. Excuse me. So that means I'm going to go from negative infinity, going from the left, from negative infinity, because negative infinity is way out this way, to negative 4.2, and then parentheses, and then from 2, or 0.2, excuse me, to infinity, because infinity's over here. Okay? And that's basically how you do number 1. Okay? So it's kind of a lot of stuff, and I know I could sit there and head through each and every one of those, but the main thing to do this problem, bless you, is make sure you can find the vertex, make sure you can find the roots and write the roots as points, okay? And then just build upon that. Does that make sense? And friends, I understand that concept of labeling all the things. It's like, how in the heck am I going to remember it? That makes you normal, okay? There's things on that list that if I hadn't seen it since last year, and I've taught it for every year for many years, I still had to sit there and go, oh, wait a minute, how do I do this? Okay, so it's not fresh in my memory, okay? So I wanted to get more to having some fun. Okay? All right. So we're going to talk about, I am on page 91. And we're going to talk about the 1-3-5 rule. Okay. So squeeze somewhere where it says 1-3-5 rule. Don't write down yet. Let me write it down, and I'll give you time to write it down. But I want you to write down kind of the order of things to do. Label A, B, C. Simple so far? It's all the same, agree? X equals negative B over 2A, and that's for the axis of symmetry and the X value of vertex. Is that okay so far? I mean, this seems similar, other than I'm writing in orange. But does this seem okay so far? Third step, plug negative B over 2A answer in for X to get Y, which would give us X comma Y, which is the vertex. Okay? So I think, though it might not be the exact 100% same words I've used, I think those are all things that we have started working with. And the 1-3-5 rule is going to be crazy. It's going to be crazy easy. And you have to trust me, my friends. Trust me. Do it the same way that we label it over and over and over again. Okay? And it will always work. Okay, so now I'm going to change this color. I'm going to purple. A times 1, 3, 5. Okay, that A value was the original A value. That was what is attached to the x squared term. And then the A value tells you whether it opens up or down. Agree? If it's positive, opens up. Negative, opens down. So I'm just going to put A is positive. It opens up. A negative opens down. Okay. Okay. This is all you need. This is all you need, my friends, to start graphing these. Okay? Notice I've left out the y-intercept. Agree? I've left out the roots because pattern graphing, especially with the ones in here, will find us the roots. Okay? I've left out, I don't know, I don't even have a table. Friends, do you feel comfortable? Do me a favor, you put your pencil down, shake your arms out for a second. Not because we're going to be writing a lot, but we're shaking out the old idea. Deal? Thanks for playing. All right. Ready? My friends, you have this one, right? So I'm just going to put a 1 right there. We good? And does everyone feel comfortable that A is 1, B is -4, and C is 3? And this is opens up because it's positive. Good so far? All right. My second step, once I labeled ABC and know if it opens up or down, is x equals -b over 2a. Agree?
Yeah.
So this is all the same we've been doing, which is going to give me 4 over 2, which gives me 2, and that's what x is equal to. So that's our axis of symmetry, but it's also our x component of our vertex. Agree? I'm just going to put plug in. Agree so far? Following my madness? Okay, so we're just going to plug that in, and we're going to get y equals 2 squared minus 4 times 2 plus 3. Now, friends, please, I know you're going to use a calculator. I know you will. I know you will. Please list when you're plugging things in, make it parentheses. When you plug it into the calculator, use the parentheses. Does this make sense? This will always assure that your calculator is going to provide you with the answer you want. Okay? And this is what I mean by this. Okay? I'm not trying to take away. Where's my graphing calculator? I know it's somewhere in here. Here it is. I want to show you how wrong the calculator is. Okay? I need you, while this is warming up, repeat this back to me. Stir up what you're showing me is the wrong answer. Ready? Stir up what you're showing me is the wrong answer. Okay. Okay. Ready? Hey, friends, if I square a negative number, it's always positive. Agree?
Mm-hmm.
So, hey, repeat what I just said. What did I say before? Okay, so what I'm showing you right now is wrong. Okay, so watch. Ready? What can you guarantee you know that answer to be? Positive 4. Does everyone feel comfortable? This is positive 4. Watch how dumb the calculator is. Okay? Now, friends, this is why I want you to put it in parentheses. If you do this, that's what you know the answer is. That top answer is wrong all day long. Now, here's the problem. You get to a test and you go, oh, -2 squared, -4. And you, oh, calculator must be right. The calculator is actually reading the top one as -1 times 2 squared. And then it's going 2 squared, which is 4. 4 times -1. That's what the calculator is doing. Okay? That's why the calculator is not giving you the answer that you want. Okay? All right, so let's finish this math. 2 squared is 4, minus 8 plus 3. So that's going to give me -1, I believe. So 2, -1. Is everybody happy? I think we should use pink next. Okay. All right, ready? The new thing we had was we did A times 135. And this 135 is just, it starts. It's actually A times 1, 3, 5, 7, 9, 11, 13, 15. You could pattern graph all the way through, but we'd actually run out of room on our graph. Okay, so with A times 135, what's my A value listed above? 1. So I'm going to go 1 times 135. And if I go 1 times 135, do you feel comfortable that I get 1, 3, and 5 for an answer? Yeah. Okay, you ready? This is going to be good. See this one right here? Ready? From the vertex. Still with me? Right one, up one. From the vertex, left one, up one. Hey, what did those two pink points just find me? They found me roots. You're exactly right. They're crossing the x-axis. So I see that I have 3, 0, and I also have -1, 0. Good so far? All right, we're going to do this one in green.
That's not -1. Yeah, that's normal.
Oh, I'm glad people are paying attention. That's +1. Boy, I tell you. +1, 0. Here, I need to erase that, make it better. This one is 1, 0. Okay, now we're going green. Okay, green is going to be for the 3. You feel comfortable? Okay, from our new pink dots. The one on the right, I'm going to go right 1, and I'm going to go up 3. From the left one, I'm going to go left 1 and up 1, 2, 3. So that's the point 4, 3. The other point is 0, 3. What's 0, 3? The y-intercept. Okay, one more to pattern graph. We'll do it blue. From our green dots now. Ready? I'm going to go right 1, up 5. And from my left green dot, I'm going to go left 1, up 5. So that's going to give me the point 1, 2, 3, 4, 5. So 5, 1, 2, 3, 4, 5, 6, 7, 8. 5, 8. And this one is going to give me -1, 8. Friends, do you see a parabola there? Do you see a parabola?
Yes. It's only 5 and 8.
It's not.
You're right.
5 plus 3 is? There's my parabola. What about the table? Oh, you wanted to fill out a table? Okay, I get -1, 8, 0, 3, -1, 0, 2, 1, 2, -1, 3, 0, 4, 3, 5, 8. Oh my goodness. We just pattern graphed, and we didn't have to go plug into a table to sit there and try and get points because the pattern graphing works. Friends, may I move on to the next problem? Waiting. We only have one problem left.
So do you guys see why having a calculator is so important, especially for this unit? It's important to always have a calculator, but especially for this unit. Go to the Dollar Tree. Dollar Tree costs $1. Get a calculator.
Hey, and I have a locker key to all the locks on campus, so we can break into people's lockers too if you guys want to join me on an off period. We'll start stealing. All right. Hey, friends, my A value is what? What's my A value? -3. What can you tell me right now about this parabola?
It's gonna be a negative.
It's going down. Agree? What's my B value? C value? Okay. Does everyone feel comfortable so far? Like, dude, this is cupcakes and sunshine all in one. All right. Now we're going to go x equals -b over 2a. This finds us the axis of symmetry and also the x part of the vertex. Agree? So I get -12 over 2 times -3, which is going to give me -12 over -6. And negative over negative this week is going to be a, and 12 over 6 is going to give me a 2. So that's my axis of symmetry. It's also the x component of my vertex. And we're going to say we're going to plug in. PI. Sound good? Or private investigator, depending upon which acronym you want. All right. So I'm going to go y equals, I know they have it at f at x, but that's just a fancy way of saying y. -3 times, that's where x used to live, plus 12 times, this is where x used to live, minus 9. So what's going in those parentheses? 2. 2 squared. 2 squared is 4. 4 times -3. -12. Good. I didn't think about that. I was like, I'm sorry. 12 times 2 is 24, I believe. And then minus 9. And then honestly, if you had a calculator, -12 plus 24 minus 9, enter. We get 3? 12? 3? Everyone feel good with a 3? All right. So 2, 1, 2, 3 right here. Agree? That's my vertex. Going pink. Okay. Now I'm going to go A times 135. What's my A value, my friends? -3. So it's going to be -3 times 135. Which gives me -3. What's 3 times 3? What's 3 times 3? -9 and -15. Now, friends, we probably won't be able to do the 15 vertical movement because it's going to go off our grid. All right? So we're going to deal with the 3 first. Hey, which way is my parabola going to open? Down. See, it's a negative number. Do you agree? Does it make sense that a negative is going to go down? So from my original dot, I'm going to go right 1 and down 1, 2, 3. And that's going to give me the point 3, 0, which is a root. And now I'm going to go back to my vertex. I'm going to go left 1 and down 1, 2, 3. And what is that point? 1, 0. And that is also a root. Okay. Now we're going to deal with the 9. So from my roots, my purple dots, my true purple, and not my kind of sort of weird purple. Well, I think that vertex is a weird purplish color. Is it purple-ish? I think the root purple is the real purple, right?
I think so.
But
it looks like a purple potato color.
Yeah, like y'all ever see me wear a shirt that color? Just, smack me upside the head saying that's a bad color.
Oh, wait, yes, I have.
All right, ready? Here we go. From our purple dot, I'm going to go right 1 and down 9. 4, 5, 6, 7, 8.
Dots are gonna be way down there.
Yeah, that's why I can't go to the 15 because it's off my page.
That's what I thought I'd do this.
So this is going to be at 4 comma negative 9, I believe. And then I'm going to go back to my purple dot, my root purple dot, left one and down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the point 0 comma negative 9. Friends, do you see the shape of a parabola? Oh my gosh. Stirrup, why didn't we learn this just the first day? I don't know. Friends, pattern graphing works. And it's following those simple rules. So let's see that blank on the bottom of this? Let's make sure we have our rules down. Can I move off this page? So on the bottom of that, let's put our rules. First thing, label A, B, C. If A is positive, up. If A is negative, down. Okay, let me just clarify. Does that kind of make sense as a very first step?
Yes.
Okay, there's an awful lot. And friends, I would, if I were you, and I know that you're teenagers, so it's hard for you to listen to an adult, but it makes you normal. Honestly, if I was doing this problem, not because I'm a math teacher, I would, just so I know, once you realize A is positive, just write up. Or if A is negative, just write down. And then make sure after you graph it, did your parabola open up or down? If you said, hey, it opens up here, and you have your parabola opening down on your graph, one of them is wrong. Does that make sense?
It'd be funny if someone got diagonal.
Diagonal? There are diagonal parabolas. We won't see them in here. Second step,
What math do you
pre-calculus and calculus. They deal with, actually, the next time you'd really see the diagonal parabola would probably be calculus 3, because you're rotating something about the z coordinate, x, y, and z. So x equals negative b over 2a. That's for the axis of symmetry. This is to find our vertex. Okay. And then our fourth step, A times 1, 3, 5. Fifth step, pattern graph. That's it. I don't know about y'all, but I love this way so much more than the other way. Make sense? So my friends, page 93, 1 through 6.
basically just
I feel blessed. Dude, who made this mess?
I don't know.
I wonder.
They only
I
got-
wonder, I think his name starts with an S.
Stupid?
Wait, that's an N.
That starts with a D. That ends
Yes,
with
it
a
does.
D.
Stupid. I was
Oh.
no, it's
Stupid.
Let's find out who can spell it. I'm kidding.
Stupid.
Oh, did you see in American Sign Language how they're
Yes.
trying to give
Yeah,
directions?
I
Oh,
saw
there's a
it.
hot mess in that.
I'm being honest.
Hot mess in a handbasket.
Yeah, and that's an issue. Don't